Section 9.2, Classifying Chemical Reactions. The objectives of this lesson are classify chemical reactions, identify the characteristics of different classes of chemical reactions. Some vocabulary review will be metal, and some new vocabulary you'll come across is synthesis reaction, combustion reaction, decomposition reaction, single replacement, double replacement reaction, and precipitate. Chemists classify chemical reactions in order to organize the many reactions that occur daily. Knowing the category of chemical reactions can help you remember and understand them. It can also help you recognize patterns and predict the products of many chemical reactions. One way chemists classify reactions is to distinguish among the four types: synthesis, combustion, decomposition, and replacement reactions. Some reactions fit into more than one of these. Sodium and chlorine react to produce sodium chloride. This reaction is a synthesis reaction. A chemical reaction in which two or more substances, A and B, react to produce a single product, AB. Two elements react, the reaction is always a synthesis reaction. Two compounds can be combined to form one compound. For example, the reaction between calcium oxide and water to form calcium hydroxide is a synthesis reaction. Another type of synthesis reaction involves a reaction between a compound and an element, as happens when sulfur dioxide gas reacts with oxygen gas to form sulfur trioxide. And if we look at figure 9.7, sodium reacts with chlorine to form sodium chloride, and even this is now balanced according to the law of conservation of mass and matter. The synthesis reaction between sulfur dioxide and oxygen gas could be classified as a combustion reaction. In a combustion reaction, such as the one shown in figure 9.8, oxygen combines with a substance and releases energy in the form of heat and light. Oxygen can combine in this way with many different substances, making combustion reactions common. To learn more about the discovery of the chemical reactions for combustions and other reactions, review figure 9.9. A combustion reaction occurs between hydrogen and oxygen when hydrogen is heated. Water is formed during the reaction, and a large amount of energy is released. Right. That's kind of indicative of a combustion reaction. When you have the one of your reactants reacting with oxygen, and it releases a large amount of heat. Water is formed during this reaction, and a large amount of energy is released. Another important combustion reaction occurs when coal is burned to produce energy. Coal is called a fossil fuel because it contains the remains of plants that lived long ago. It is composed primarily of the element carbon. Coal-burning power plants generate electric power in many parts of the United States. The primary reaction that occurs in these plants is between carbon and oxygen, which usually results in the production of carbon dioxide gas. Note that the combustion reactions just mentioned are also synthesis reactions. However, not all combustion reactions are synthesis reactions. For example, the reaction involving methane gas, CH4, and oxygen illustrates a combustion reaction in which one substance replaces the other in the formation of products. Right? So methane plus oxygen gas gives us carbon dioxide and water. Methane belongs to a group of substances called hydrocarbons. Is the major component of natural gas. All hydrocarbons contain carbon and hydrogen and burn in oxygen to yield carbon dioxide and water. Go ahead and take a moment to go ahead and practice these four problems. All right, write the chemical equation for the following reactions Give yourself some practice too. Try balancing them out. And then go ahead and classify them as much as possible. So here are your answers to those reactions, as well as them being balanced out. Some chemical reactions are essentially the opposite of synthesis reactions. These reactions are classified as decomposition reactions. A decomposition reaction is one in which a single compound breaks down into two or more elements or new compounds. In generic terms, decomposition reactions can be represented as the following. AB yields A plus B. Decomposition reactions often require an energy source, such as heat, light, or electricity to occur. For example, ammonium nitrate breaks down into dinitrogen monoxide and water when the reactant is heated to high temperature. Notice that the decomposition reaction involves one reactant breaking down into more than one product. The outcome of another decomposition reaction is shown in figure 9.11. Automobile safety airbags inflate rapidly as sodium azide pellets decompose. A device that can provide an electrical signal to start the reaction is packed inside airbags along with the sodium azide pellets. When the device is activated, sodium azide decomposes, produces nitrogen gas that quickly inflates the airbag. So go ahead and take a second and try and balance out the following reactions. Right. Go ahead and balance them out. And here are your following decomposition reactions that have been balanced. In contrast to synthesis, combustion and decombustion reactions, many chemical reactions are replacement reactions and involve the replacement of an element in a compound. These reactions are also called displacement reactions. There are two types of replacement reactions: single replacement reactions and double replacement reactions. The reaction between lithium and water, shown in figure 9.12, is a single replacement reaction. The following chemical equation shows that a lithium atom replaces one of the hydrogen atoms in a water molecule. Two lithium atoms and two water molecules go ahead and produce two lithium hydroxide formula units, as well as a molecule of hydrogen gas. A reaction in which the atoms of one element replace the other atoms of another element in a compound is called a single replacement reaction, in which A plus Bx yields Ax plus B. The reaction between lithium and water is one type of single replacement reaction, in which a metal replaces a hydrogen atom in a water molecule. Another type of single replacement reaction occurs when one metal replaces another metal in a compound dissolved in water. Figure 9.12 shows a single replacement reaction occurring when a bar of pure copper is placed in aqueous silver nitrate. The crystals that are accumulating on the copper bar are silver atoms that the copper atoms displaced. So copper plus silver 1 nitrate will yield us silver metal as well as copper 2 nitrate. A metal will not always replace another metal in a compound dissolved in water because metals differ in their activities. Reactivity is the ability to react with another substance. In an activity series of some metals is shown in figure 913. The series orders metals by reactivity with other metals. Single replacement reactions are used to determine a metal's position on the list. And the most active metals are at the top, whereas the least active metals are more on the bottom. Halogens are also ranked there as well. And there's kind of a rhyme in the reason for the halogens, fluorine being the most, iodine being the least, and it kind of follows down the same family. But if we take a look at this, lithium, rubidium, potassium have the most active metals, whereas silver, platinum, and gold are the least active of the metals. And we would go ahead and use this single replacement chart to go ahead and predict whether a metal would be able to go ahead and replace another metal in a given compound. If the solid metal is more active than the metal in the aqueous compound, then yes, it would be able to go ahead and replace it. You can use the activity series to predict whether or not certain reactions will occur. A specific metal can replace any metal listed below it in that is in a compound. It cannot replace any metal listed above it. For example, copper atoms replace silver atoms in a solution of silver nitrate. However, if you were to go ahead and place silver wire in aqueous copper 2 nitrate, the silver atoms will not be able to replace the copper. Silver is listed below copper in the activity series, so no reaction occurs. The letters NR, which mean no reaction, are commonly used to indicate that a reaction will not occur. If we go ahead and look at this, right, copper is above silver, right? Because the copper metal is above the silver in the silver 1 nitrate, we would anticipate a chemical reaction. But silver metal cannot displace the copper 2 in copper 2 nitrate. And that's what we see here. A third type of single replacement reaction involves the replacement of a nonmetal in a compound by other nonmetals. Halogens are frequently involved in these types of reactions. Like metals, halogens exhibit different activity levels in single replacements. The reactivity of halogens determined by single replacement reactions are also shown in that figure of 913. The most active halogen is fluorine, and the least active is iodine. A more reactive halogen replaces a less reactive halogen that is a part of a compound dissolved in water. For example, fluorine replaces bromine in water containing dissolved sodium bromide. However, bromine does not replace fluorine in water containing dissolved sodium fluoride. And because fluorine here is more active than the bromine here, we're able to go ahead and see that fluorine displace the bromine, forming sodium fluoride. But because bromine is not more reactive than the fluorine, we would not see a chemical reaction occur. Right. Let's go ahead and predict whether we would go ahead and get a chemical reaction. What would our products be if we were to go ahead and get that and go ahead and balance for the following 3 equations. So you're given 3 sets of reactants, and we have to go ahead and use that activity series to go ahead and predict if a reaction would go ahead and occur. And if a reaction is predicted, you can go ahead and determine the products of the reaction. Right? So if iron were to go ahead and react with copper 2 sulfate, right, the iron being more active than the copper would displace the copper and give us iron 2 sulfate as well as copper metal. Here we have bromine, right, Br2, reacting with magnesium chloride. Because bromine is not more reactive than chlorine, we would not get a chemical reaction. Now if we were to look at this one, here we have magnesium is more active than the aluminum, so that magnesium would displace the aluminum and give us magnesium chloride as well as aluminum metal. Now we just got to go back and balance it, and to go ahead and balance this, refer to 9.1, we would get a 3:2:3 ratio. Go ahead and pause the video and try these practice problems. Right? Predict whether the following single replacement reactions will occur. And if a reaction occurs, write a balanced equation for the given reaction. So here are the answers to the single replacement reactions as well as the balanced equation for the said reaction. The final type of replacement reaction, which involves an exchange of ions between two compounds, is called a double replacement reaction. In the generic equation in figure 914, A and B represent positively charged ions, or we'll call them cations, and X and Y represent the negatively charged ions, or anions. Notice that the anions have switched places, are now bonded to the other cations in the reaction. In other words, X and Y, X replaces Y, and Y replaces X, a double replacement reaction. More simply, the positive and negative ions of two compounds switch places. Okay, that's what we can kind of see in this diagram here, right? Is that we have AX plus BY, which is going to yield us AY plus BX. The reaction between calcium hydroxide and hydrochloric acid is a double replacement reaction. The ionic components in the reaction are calcium ions, hydroxide ions, hydrogen, and chloride ions. Knowing this, you can see the two replacements of the reactions. The anions, hydroxide and chloride, have changed places and are now bonded to the same cations, to the other cations, calcium and hydrogen. The reaction between sodium hydroxide and copper 2 chloride in the solution is also a double replacement reaction, in which sodium hydroxide plus copper 2 chloride yields sodium chloride and copper 2 hydroxide. Notice how in these equations we're always starting with something that's both our reactants are aqueous, but we're always going to end with either one aqueous compound and the other compound is going to be either a liquid, a solid, or a gas. In these cases, the anions changed places and bonded with the other cations. A solid produced during a chemical reaction is called a precipitate. And a couple guidelines to go ahead and writing double replacement reactions. First thing you want to do is write the components of the reactants in a skeleton equation, and then identify the cations and the anions in each compound. Pair up each cation with the anion from the other compound, and then write the formulas for the products using the pairs from the previous step. Write the complete equation for the double replacement reaction, and then go ahead and balance it in the end. One of the key characteristics of double replacement reactions is the type of product that is formed when a reaction takes place. All double replacement reactions produce either water, a precipitate, or a gas. Refer back to the double replacement reaction previously discussed in this section. The reaction between calcium hydroxide and hydrochloric acid produces water. A precipitate is produced in the reaction between sodium hydroxide and copper 2 chloride. An example of a double replacement reaction that forms a gas is that of potassium cyanide and hydrobromic acid. It is important to be able to evaluate the chemistry of double replacement reactions and predict the products of the reactions. The basic steps are written down in Table 9.3. Go ahead and pause the video and write the balanced chemical equation for the following double replacement reactions. So here are the balanced equations for the following double replacement reactions. Table 9.4 summarizes the various types of chemical reactions. Use the table to help you organize the reactions so that you can identify each and predict its products. For example, how would you determine that the type of reaction occurs when a solid calcium oxide and carbon dioxide gas react to produce solid calcium carbonate? First, write the chemical equation. Right, CaO plus CO2 yields CaCO3. Secondly, determine what is happening in the reaction. In this case, two substances are reacting to form one compound. Third, use the table to identify the type of reaction. The reaction is a synthesis reaction. Fourth, check your answer by comparing the chemical equation to the generic equation for the type of reaction. In this case, A plus B yields AB. Section summary of 9.2. Classifying chemical reactions, make them easier to understand, remember, and recognize. Activity series of metals and halogens can be used to predict single replacement reactions will occur.